solving radical equations. And so at some point in the equations, we'll get to places where the last thing we need to do is take a root or a rational exponent. So we've done this before, it's just a little warm up for our lesson today. You can type that in your calculator and get the correct answer, or you can use our power over root to get the correct answer. So either way, doesn't matter to me. I know we had one assignment one time that said without using a calculator, but I don't care if you use a calculator. But I'm gonna do power over root on both of these real quick. So power would be 64 to the second power, which I don't know what that is, but I do know what the cube root of 64 is. The cube root of 64 is 4, and then I still haven't done the squared yet, so you would end up getting 16. Everybody got that? Do I need a plus minus?
No.
No, because my root was an odd number, my root was 3. Okay, so same thing over here, negative 32 to the third power. I don't know what that is, but I do know the fifth root of negative 32, and that's a common one. When we start getting higher roots and you think, oh, I don't know how to do those, they use pretty common stuff a lot of times. So 2 to the fifth is 32, but since we're negative, it'll be negative 2, because you can do an odd root with a negative. And then I need to cube that, so negative 2 times negative 2 times negative 2 would have got you negative 8. You get them? All right, let me smear that off there, and we will solve some equations now. I'll just erase the problem. That's okay, I can get it back there. Negative 32 to the 3/5, is that what it was? All right, so solving these things today, this is the fun stuff. We had to wait all unit to get to it. We got the cube root of 2x plus 7 is equal to 3. Okay, now these are pretty simple to start off. We'll fly through some easy ones and finish up with the more difficult deal. But it's the same concept as when you solved equations in middle school. You're just trying to isolate the variable. That means get the letter all by itself. And in order to do that, you undo what's happening. And when we undo stuff, opposite operation. So right now on the whole left side, this whole big chunk is being cube rooted. So I would want to undo a cube root. What undoes a cube root?
Cube it.
Right? So we're going to raise that whole side to the third power. And if we do it to the left side, we got to do it to the right side. Okay, so over here on the left, the cube root and the cube cancel each other out. So we just have 2x plus 7. And then over here on the right, we got to figure out what 3 cubed is. So type it in your calculator if you don't know. 3 times 3 is 9 times 3 is 27. Now we went from what looks difficult to a 2-step middle school equation. What's step 1 in solving this?
Add yourself.
Close, that'd give me 14.
Oh wait, no, not subtract.
Subtract your 7, very
However
good.
you say it.
So that gets me 2x is equal to 20. Then what? Divide by 2. And we get x is equal to 10. Now, what we're going to see today is we're going to have to check our answers a lot. You know, usually a lot in the past, your teachers have told you check your answers, but, you know, you could get away with really not doing it. But because these are going to be limited with the radicals, you know, there's only certain types of numbers you can take roots of, we're going to have to start checking our solutions with these. And what we're going to find is sometimes we're going to get what's called an extraneous solution. That's a big old $10 word, an extraneous solution. It means you do all this good work and you get a good answer like we did, but then you plug it back in and it doesn't work. So let's just do some mental check now and see if we can plug this 10 back in mentally. 2 times 10 is 20. 20 plus 7 is 27. Is the cube root of 27 3?
Yeah.
Yeah, so this time it works, so that's a good solution. We're going to have to do that on these to make sure it checks out. All right. Pretty easy. Y'all like that, don't you? Let's look at this one. Starts off a little bit different because this time only the x is being cube rooted. So we got the cube root of x, and I spaced mine way over so I didn't get confused. The cube root of x minus 9, and the minus 9 is not underneath the radical, is equal to negative 1. So my first step in this one is not going to be the same as my first step in the last problem, because this whole chunk is not underneath the radical. So what we want to do when we only have part of a thing underneath the radical
is you wanna get rid of extra junk. So what would be extra junk on this left side that I'm gonna get rid of first?
The -9.
The -9, so we're gonna add 9 to both sides. So that'll bring down my cube root of x is equal to -1 plus 9 is 8. So now there's nothing left but the cube root, so get rid of the cube root. But do you see why we didn't get rid of it first? If we'd have got rid of it first, we would have had to have cubed this whole thing, which would have actually meant write this whole thing out 3 times and multiply together. Woo, that'd have been tough. Alright, so we're gonna get rid of the cube root. Let me get a new color to write my cube. Well, that's gonna be a big answer, isn't it? Cube root and cube cancel out on the x, so we just got x. 8 cubed. I don't know that one in my head. 8 times 8 is 64. 64 times 8 is
512.
512. Okay,
That's a lot.
now let's check it real quick. This is going to be easy to check because the cube root of 512, well, we just figured out what 8 cubed was, right? So the cube root of 512 will be 8. 8 minus 9 is that -1. Winner, winner, chicken dinner. And I promise we'll see some that don't work in a little bit. That's why we got to keep checking them. Okay, let's look at one more on this level that starts off a little different before we step the level up. I got 2 times the cube root of x minus 3 is equal to 4. Alright, so what should we do first here? We haven't done one like this yet, but what do you think? What should we do first?
I would say.
Good. We still have some extra junk. We're gonna get rid of this 2. Okay? So it's being multiplied, so what would get rid of that? Divide both sides by 2. So 2's cancel out over here. Just have the cube root of x minus 3 is equal to 2. Now we've done one just like this before. Now on the left side, that whole quantity is being cube rooted. So undo that. What undoes it?
QE.
Cube. So we're going to cube and cube. So it cancels out over here. I just got x minus 3, and over here 2 cubed is 8. Just got one step left.
Thank you.
Add your 3, so we get 11. Alright, let's see how we do with that. That's going to be able to circle that or not. 11 minus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. So true statement, circle that dude up, bada bing, bada boom. Alright. I like these. Now, let's switch it and look at a rational exponent. 4x to the 2/3 is equal to 36. Okay, so the new dilemma for us now is that rational exponent. That is the new thing we're going to talk about attacking. But before we attack that, let's go ahead and see if there's any extra junk with the x to get rid of. What do you think?
The 4.
The 4 is being multiplied, so we're going to divide. So we got x to the 2/3 is equal to 9. Okay, so now what we're wanting to do, we're trying to get the x all by itself, so we need to get rid of a 2/3 power. And you could think, well, okay, let's rewrite it doing power over root. And you could do that. That would give you a power and a root that you're going to get rid of both of them. So that would create 2 steps. I bet we can figure out a way to get rid of it in 1 step. So if I could, this is my thought process, when I have a rational exponent I need to get rid of, if I could raise that to some power out here that would cancel it out, that would be the easiest thing to do. So if I put some power out here where that question mark is, that's power to a power, and that multiplies. So I'm trying to figure out 2/3 times what would equal 1. What could I raise this to that would cancel that out? Okay, let's back up to a baby fraction. 2/3 might be too hard for us. 1/2 times what would equal 1?
2.
And isn't 2 the same as 2/1? So what type of numbers do we call these? Starts with an R. Reciprocal, very good. So I wonder if I took the reciprocal, like Zach said, of 2/3, and I multiplied that, would that equal 1? 2 times 3 is 6, 3 times 2 is 6, 6/6 is 1. So it's always the reciprocal. You can multiply a fraction by its reciprocal and get the number 1. So I want to raise, let me erase my question mark. I want to raise the left side to the 3/2 power, but also have to do that to the right side. Okay, so over here, 2/3 times 3/2, we just figured out is 1, so we just have x to the first. Now I gotta figure out what 9 to the 3/2 power is, and that's why I gave you those bell ringers. So you can type 9 to the 3/2 in your calculator, or you can do 9 to the 3rd and take the square root. Square root of 9 is 3, so 3 cubed is 27. So I'm looking at 27, does it need a plus minus sign?
Yes.
Yes, I did a square root, I did an even root. See right here, my root was 2. So anytime we do an even root is when we get the plus minus sign. Now, these, in my opinion, are a little bit more difficult to check. So you would do 27 to the 2/3 power, then multiply it by 4, and see if you get 36. So 27 to the 2/3, be the cube root of 27 is 3, 3 squared is 9, 9 times 4, so that is 36. Is that what you were gonna ask? You were gonna ask something.
Like if you use the calculator to get 27, how do you know whether you use a plus or minus?
That's a good question, because it's not gonna tell you. You have to know that you did an even root. So anytime the bottom number's a fraction is an even, that means it's an even root. Whoop, whoop, whoop. Alright, let's look at x plus 2 to the 3/4, and then minus 1 is equal to 7. Alright, so there's extra junk. You're always gonna get rid of extra junk not involved in the radical or exponent first. So what's our extra junk to get rid of?
-1.
-1, so we're gonna add 1 on both sides. So we got x plus 2 to the 3/4 is equal to 8. Okay, now when we have a rational exponent, this means a fraction exponent, we want to make that a 1. So what could we raise this power to that would change 3/4 to a 1? 4/3, 4/3, so we're gonna do to the 4/3, and whatever you do on the left, you gotta do on the right. So here, that makes 12/12, which is just 1, so we're just left with x plus 2. Power over root, and you can type that in your calculator. The cube root of 8 is 2. 2 to the 4th is 16. Does that 16 need a plus minus sign?
No.
No, because I did a cube root, very good. I got one step left.
Subtract 2.
Subtract 2. Was that easier that time? Once you remember that reciprocal trick, not a lot to it, right? Alright, let's look at a couple more. This one I've got x plus 1
No, the one we did before also checks out.
Oh, my bad, I forgot. I'm glad you're paying attention, but Tyler did, let me rewind. Tyler plugged the 14 back in, so 14 plus 2 is 16. The fourth root of 16 is 2, 2 cubed is 8, 8 minus 1 is 7. So good job, Tyler, for keeping me on track there. Thank you, thank you, thank you. Lost my mouse. There it is. Alright, so let's look just a couple more. X plus 1 is equal to the square root of 7x plus 15. Now this one is stepping it up a level, and then the last one that we're gonna do next is the big whammy, stepping it up a little. And one thing that might tell you that is you've got a variable on both sides here, so that's gonna present a problem. We do need to try to get rid of that square root first. So what would we do to get rid of that square root?
Square it.
So we're gonna square this side, which also means we have to square this side. And I wrote it like that on purpose because this doesn't just square the x and the 1. That's a whole quantity. So we have to write that quantity twice and multiply it out. Okay? So over here we're going to have x plus 1 times x plus 1. Over here the square and square root do cancel out. So we're looking at that. But we got a little bit of work to do right here now. We got to either say FOIL or distribute, whatever you want to do on that. Here's x squared. Here, you're going to get a 1x, and also here, you're going to get a 1x. So what does that give me on my x's? A 1x, and a 1x is a 2x. And then there, I got a 1 times 1. Okay, so what type of problem have we just created? What's it called when the degree is 2?
Quadratic.
Quadratic. So that means that we're going to have to set this thing equal to 0 and then either try to factor it or do the quadratic formula. So I would subtract 7x from itself and its buddy, and I would also subtract 15. You can do that in 2 steps or 1, it doesn't matter, from itself and its buddy. So we're looking at x squared minus 5x minus 14 is equal to 0. So now if you want to do the quadratic formula, you got an A of 1, a B of negative 5, and a C of negative 14. You can do that. I think this one will factor. Factors of negative 14 that add negative 5 would be negative 7 and positive 2. So I'm going to do that. So I'm going to write, come on scroller, I'm going to write x minus 7 times x plus 2. And now I just set both of those equal to 0 and solve, so I get a 7 and a negative 2. Okay, everybody all right on that? And that's what you'd have gotten if you'd have done the quadratic formula, just might have taken you a minute more. So my dilemma that I have now is I've got 2 answers to check, and here's the different scenarios for it. Both of them could work, one of them could work, or none of them could work. So let's take the 7 back to the original problem, plug it in. 7 plus 1 is 8. 7 times 7 is 49. 49 plus 15 is 64. Square root of 64 is 8. So 8 does equal 8. Okay, what was our other one? Negative 2.
Mm-hmm.
Negative 2 plus 1 is negative 1. And now, some of us already know this can't work, because I'm fixing the square root the whole other side, and I can't have a negative square root. But let's go ahead and see what it looks like. 7 times negative 1 is negative 7. Negative 7 plus 15 is 8. Square root of 8. It's 2 square roots of 2. Is this a true statement?
No.
No. So the negative 2 did not work, so you, come on scroller, you just get to kick it to the curb, and there's your one answer on that one. So when you're checking, you're just looking for if that's a true statement or not. Alright, so this last one that I got is what y'all would say is the hard one of the day. So let me write it all down here.
I did some working it all over my book when I was working on it yesterday. Square root of x plus 2 plus 1 is equal to the square root of 3 minus x. Okay, so in the last problem I put a variable on both sides. This problem, not only do we have a variable on both sides, we also have a radical on both sides. So you are gonna undo a square root with a squared, that's still the same, but we gotta zone in and make our minds believe which one of these square roots we're actually attacking. And here's the one you're gonna attack, the one that has no extra jump. So this one has no extra jump. See, this one does? So we're gonna attack that one. So we're gonna say, let's undo this square root by squaring, same thing over here. Now, on the right side, just like on the last problem, when we square this, that means we have to write that twice and multiply it all out. So I gotta take that twice. And the reason why is it not just cancel out, it all is because of the extra jump. Anytime there's extra jump, you got more multiplying to do, and it doesn't just cancel it out. It only cancels it out like over here when there's nothing extra. So here the square root will cancel out. So you're just gonna have 3 minus x. All right, now this multiplication on the left side can get cumbersome, but let's just use some common sense as we go about it and see what happens. First thing I'm gonna do is distribute right there where I drew that line. Now that's the same thing, isn't it? The square root of something times the square root of something, and the somethings are the same. So let's think of this like a kid here. Let's do some little stuff. This is the same concept. So if I were to multiply this out, square root of 2 times the square root of 2 is the square root of 4, which is 2. So when you're multiplying a square root by itself, what you end up with is just what was underneath. Okay, so where I've got my lines drawn there on the smart board, the square root of x plus 2 times the square root of x plus 2 is just going to be x plus 2. The square roots will just cancel out, just like here, 2, 2, 4, 2, they cancel out. Okay, so now I got to take the square root of x plus 2 to that 1, which just will make the square root of x plus 2. So I'm done distributing this, right? Now we got to distribute the 1. So here I take the 1 and I get square root of x plus 2. And then here, 1 times 1 gives me a 1. Now this is ugly, but think of that as like we did with our guitars that day. These are the same. So guitar and guitar, one of them and one of them. So we're going to write x plus 2. Now there are 2 of those guitars. And I know I haven't been bringing the right side down yet, but we still got to keep cleaning up this left side first anyway. Now, on the left side, we got like terms right there. So I've got x plus 2 square root of x plus 2 plus 3, and if you wrote that in a different order, that's fine. Okay, let me bring down my right side to the party now. Okay, so now we've gotten what started off with a radical on both sides, we got it down to just one radical. So we need to try to see if we can start getting rid of that radical now. So we attacked the right side first, got rid of its radical. Now we got to clean this side up and get rid of it. So here's your radical. You got a lot of extra junk there to get away from it. So I might, the scroller would work. I might subtract 3 from itself and its buddy. Okay. I could subtract x from itself and its buddy. Let's just do that first. There's still one more step, but let's just do that first. That'll give me 2 square roots of x plus 2. 3 minus 3 is 0. Negative x minus x is negative 2x. Okay, that's getting there. There's still a piece of extra junk to get rid of. With the radical, what extra junk is there still?
2, and it's being multiplied, so we're gonna divide. So I got the square root of x plus 2 is equal to negative 1x, right? Come on, scroll for me, I know, we're getting close. Alright, so now there's no extra junk on the left side. What are we gonna do to get rid of that square root?
Square it.
Square it. So we're gonna square here, we're gonna square here. So square and square root cancel out. What do I get on the right when I square a negative x?
X.
Positive x squared, right? Negative times negative is a positive and it's squared. Okay, so here we are with another quadratic. Either use the quadratic formula or factor, but either way you gotta set it equal to 0, so I like to keep my a positive, so I'm gonna keep this here, and I'm gonna subtract my x and subtract my 2. So I'm gonna end up with x squared minus x minus 2 is equal to 0. So you got an a of 1, a b of negative 1, a c of negative 2, negative 2 and positive 1 if I wanted to factor, right? So set both of those equal to 0 and you get 2 and negative 1. Whew, that was fun, but we still gotta check them. So we're gonna take the 2 up there first, all the way to the top. Come on. There, almost. Alright, so right here, 2 plus 2 is 4. Square root of 4 is 2. And then plus 1 is 3, so we got a 3 on that side. 3 minus 2 is 1. Square root of 1 is 1. Does 3 equal 1?
No.
No, so 2 cannot work. Okay, what was our other answer? Negative 1? Negative 1 plus 2 is 1. Square root of 1 is 1. 1 plus 1 is 2. 3 minus negative 1 is 4. Square root of 4 is 2. So 2 does equal 2. So let me jump back down to the bottom to my answers. This one was no good. Winner, winner, chicken dinner. What was the big $10 word that we would call 2? Starts with an E. When you do all the work and you get an answer but it doesn't check. Extraneous. An extraneous solution. Okay, the solving part of every unit is always my favorite. I feel like I'm more useful in solving than I am just worried about domain and range and all that. So I think that's some good stuff there. You got a lot of good problems on that. Tomorrow we're gonna pretend like our study guide's a test. Okay, we're gonna work on it, pretend like it's a test the whole period. Then if you do well and work hard on that, Monday I'll go over it. If not, Monday we'll just take the test. So that'll be on y'all. But the plan is to Monday go over it and Tuesday take it. Okay, everybody good? Woohoo!